Hormones and the endocrine system.
Good day, everyone! Did you know that the word endocrine derives from the Greek words endo, meaning inside or within, and krinis for secrete? The endocrine system is the organ system consisting of ductless glands that secrete hormones.
What are you watching there? Ah, body systems. So which ones have you learned about? Ah, the muscular system, the skeletal system, the circulatory system, the nervous system, and so many more. It's wonderful that you know so much about your body. Oh, you enjoy music too. Did you know there's a body system that works just like the conductor or music director of this orchestra? It is this system of our body whose organs control and direct the other body systems. Well, it is called the endocrine system. Just as the different musicians in an orchestra need someone to tell them when, how, and what to play, so is it with the organs of our body. Our body organs also need someone to tell them what should be done at what time. Not that organ. Organs of our body need direction from a central control system. The endocrine system does this job. It is the central control system. So can you tell me what the name of the system is? Oh no, it is the endocrine system. The endocrine system is a signaling system that works in conjunction with the nervous system to control and regulate the body. In contrast to the nervous system, which uses electrical signals to affect this, the endocrine system communicates using chemical signals called hormones. These hormones are used to control growth and development, metabolism, reproductive processes, and even affects our mood. Hormones are produced by the endocrine glands and ends in the bloodstream, where they circulate around the body. They are key to specific tissues, and once recognized, they signal the tissue to perform a task. Due to the rapid and brief nature of nervous impulses, endocrine signals are relatively slow and act for a prolonged period.
The endocrine system has many glands. These glands make hormones that control the functioning of our body systems. Oh, whoa, take it easy, my friend. I'll explain it to you in detail. You see, our body has many small organs called glands. These glands together make up the endocrine system. Each gland has a special job. Let me introduce you to your glands. First, meet the pituitary gland, the boss of all endocrine glands.
The pituitary gland is about the size of a pea and is known as the master gland because it regulates all the other glands and tissues that comprise the endocrine system. It is located at the base of the brain and is connected to the hypothalamus, which in turn regulates its activity. It is part of the nervous system located in the diencephalon or interbrain. This is where the nervous system and the endocrine system shake hands as it works. The hypothalamus is involved in the control of our body, temperature, emotions, and sexual activity, among many other things. These activities are initiated by the hypothalamus based on negative feedback. The hypothalamus accomplishes this in three ways. 1. The hypothalamus regulates the anterior pituitary gland by stimulating or inhibiting the production of the pituitary hormones. 2. The hypothalamus releases hormones directly into the circulatory system through the posterior pituitary gland. And 3. The hypothalamus controls the endocrine cells up to the adrenaline medullae, which produce a very important hormone called adrenaline. The pituitary gland has two lobes, the posterior lobe and the anterior lobe. The anterior pituitary gland is connected directly to the hypothalamus by a capillary network called the hypophyseal portal system. Two types of regulatory hormones are produced by the hypothalamus and transport it directly to the anterior pituitary gland, releasing its hormones and inhibiting hormones. These hormones in turn regulate the production of hormones by the anterior pituitary gland. The hormones produced by the anterior pituitary gland include thyroid stimulating hormone or TSH, that triggers the thyroid gland to secrete thyroid hormones. The adrenocorticotropic hormone, or ACTH, that stimulates secretion of hormones in the adrenal glands. The follicle-stimulating hormone, or FSH, that stimulates sperm production in the male testes, as well as it stimulates estrogen hormone secretion and egg development in the female ovaries. The prolactin, or PRL, that stimulates the formation of mammary glands in the female and the production of milk. The luteinizing hormone, or LH, that induces ovulation in females and stimulates estrogen and progesterone hormone secretion in preparation for pregnancy. It stimulates the production of testosterone hormone in the testes. And the last one, the growth hormone, that targets cells in the liver which are involved in processing food as well as stimulating cell growth and replication throughout the body.
Next one is the posterior pituitary gland, which contains neuron cells that originate in the hypothalamus, and it releases two hormones that are produced in the hypothalamus. The antidiuretic hormone, or ADH, which targets cells in the kidneys and works to maintain a proper balance of electrolytes in the bloodstream. And it is also involved in maintaining proper blood volume and proper blood pressure. The oxytocin, which helps prepare the uterus during the last stage of pregnancy for labor and delivery. It is also involved in producing milk in the mammary glands. Next comes the thyroid gland, the growth agent, together with the parathyroids.
There are 4 parathyroid glands located behind the thyroid glands. Parathyroid glands monitor and controls the amount of calcium in our blood and bones by secreting a hormone called parathyroid hormone, or PTH. Each gland monitors the blood calcium and responds by making more or less. Hyperparathyroidism is a disease of the parathyroid glands, affecting 1 of 800 people during their lifetime, and 1 in 250 women over age 50. Since parathyroid glands control the levels of calcium in our bodies, hyperparathyroidism is a disease of improper calcium regulation. Hyperparathyroidism is a disease that occurs when one of the parathyroid glands develops a tumor. This tumor produces far too much parathyroid hormones, which is released into the bloodstream. The excess parathyroid hormone travels through the blood and into the bones. The hormone activates cells within the bones to eat away at the bones, often causing osteoporosis, fractures, and bone pain. The destruction of bone releases calcium into the blood. High blood calcium levels are seen in almost all patients with parathyroid tumor. The excess calcium can build up in the arteries, increasing atherosclerosis throughout the body. This can lead to high blood pressure and increased risk for heart attack and stroke. The high calcium often affects the electrical system of the heart, causing atrial fibrillation and palpitations. The excess blood calcium builds up in the kidneys, forming kidney stones, and occasionally causing kidney failure. High calcium levels also affect the brain, since we use calcium in the electrical system of our nerves. A high blood calcium is associated with a slower nervous system, which gives symptoms of tiredness, memory loss, and poor concentration. Many patients with high blood calcium have chronic fatigue for this reason. High calcium levels have an effect of the stomach and the intestines, often causing gastroesophageal reflex disease, also known as GERD, and abdominal discomfort. High blood calcium is even associated with higher risk of several cancers, including breast, prostate, colon, and kidney, some of which are more than twice as common in patients with high blood calcium. It is estimated that untreated hyperparathyroidism can decrease a patient's life expectancy by 5 or 6 years, even when the calcium is slightly elevated. There are no drugs, pills, or other treatments that can slow the process of bone destruction or take the place of surgical removal of the parathyroid tumor. Hyperparathyroidism is cured by surgical removal of the parathyroid tumor. In the hands of an expert, parathyroid surgery is a straightforward outpatient procedure that can often be completed in less than 20 minutes. Since as many as 30% of patients with hyperparathyroidism will have more than one parathyroid tumor, your surgeon will examine all four parathyroid glands to be sure the second tumor is nothing left behind. Once all parathyroid tumors have been removed, the disease is cured. The process of eating away at the bones stops within minutes. Bone pain is typically gone within a few hours. The bones begin to regenerate within days, and the osteoporosis begins to improve. The excess calcium in the blood will be gone within few hours, and within a week or two, most patients feel significantly better. Risks of high blood calcium begin diminishing within days of parathyroid tumor removal. Hyperparathyroidism is a disease that typically makes people feel bad while it slowly destroys their body. All patients with hyperparathyroidism should be evaluated for a straightforward operation to remove the parathyroid tumor. Curing this disease has a tremendous impact on a patient's overall health. Right on top of the kidneys are the adrenal glands.
During periods of stress, such as preparing to run in a race, the brain signals the adrenal glands to produce epinephrine or adrenaline. Epinephrine increases the rate in which the heart beats. In turn, the increased cardiac output supplies more oxygen to the muscles, putting the body in a heightened state to react. As a longer-term response to stress, cortisol is secreted by the adrenal glands, promoting the release of energy.
The next one is the pancreas.
As an example of how parts of the endocrine system works, consider the pancreas. In addition to aid in digestion, the pancreas also serves as an endocrine function which regulates blood sugar levels. High blood sugar causes the pancreas to release hormones called insulin into the blood. When levels of blood glucose or sugar become too high, the pancreas increases production of insulin. Chemicals in the insulin cause body cells to open up, allowing more glucose from the blood to enter cells, stabilizing the amount of glucose in the blood and maintaining adequate energy in the cells. When this reaches the liver, it signals the liver to convert sugar into glycogen for storage. This reduces the blood sugar levels, which reduces the stimulus of pancreas to produce insulin, and insulin levels fall. This slows down the conversion of liver and eventually stops altogether when optimum levels have been achieved. When blood sugars level fall, the pancreas releases another hormone called glucagon which stimulates the liver to convert glycogen back into sugar, and again restore the optimum blood sugar level.
When food is ingested, it travels along the digestive tract where it is broken down into its complete nutrients in order to be absorbed into the bloodstream. One such nutrient is glucose, a simple sugar. Glucose gets absorbed by the stomach and intestines and then enters the bloodstream. It travels through circulation to all body cells. Once absorbed into the bloodstream, glucose circulates, causing the blood sugar level to rise. An increased level of blood sugars sends a signal to the pancreatic data cells, which respond by secreting the hormone insulin into the circulation. Insulin is necessary for glucose to reach and be used by several important target tissues of the body. These include the liver, muscle, and fat. Insulin is necessary to keep blood glucose levels stable in the body. Glucose enters the cell to a process called facilitated diffusion.
There are two types of diabetes, type 1 and type 2. Type 1 diabetes accounts for about 15% of all cases. It's most often found in the under 40s and is by far the most common type of diabetes found in childhood. In type 1 diabetes, the carbohydrate containing food is broken down into glucose as normal. That glucose then moves into the bloodstream. Normally, the body would produce insulin to let that glucose into the cells. But in type 1 diabetes, there is no insulin being produced, so the glucose can't get through the body cells at all. So the level of glucose in the blood rises and rises. The body tries to lower the level of glucose, tries to get rid of the glucose through the kidneys. That's why people who have undiagnosed type 1 diabetes tend to go to the toilet a lot to pass urine. As for kidneys filter the glucose enters the blood, they also take a lot of water with it, so the person with diabetes will get very thirsty. The urine contains a lot of glucose, and that creates an environment where it's quite safe for bacteria to thrive, so it is also quite common to get thrush or genital itching. In the same way, the blood contains the high level of glucose as well, so more bacteria than usual will tend to breed in flesh wounds and make this slow to heal. Glucose can also build up in the lens of the front of the eye, causing the liquid in the lens to become cloudy. That could mean that some people with undiagnosed type 1 diabetes can have blurred vision because the glucose can get into the cells to be used for energy. Somebody who's got undiagnosed type 1 diabetes is going to start feeling very tired, lethargic, and unable to go back to their original routine. But the body still needs energy source in order to work properly. So what it does is it starts to break down its fat stores, and that can lead to weight loss. So the main symptoms of type 1 diabetes are going to the toilet a lot, thirst, thrush, or genital itching, slow healing of wounds, blurred vision, tiredness, and weight loss. These symptoms generally happen quite quickly, often after a few weeks, and can be reversed once the diabetes is treated with insulin. Type 2 diabetes accounts for about 85% of all cases in the population. It is most common in the age over 50, in white population, and the over 25's age group in Black and South Asian population. Type 2 diabetes is a little more complex because of slightly more processes at work. Either the body isn't producing quite enough insulin, or the insulin still producing isn't working properly. That can lead to becoming overweight because of the buildup of fat can stop insulin doing its job properly, but can also happen in people with a healthy weight. So in type 2 diabetes, the carbohydrate containing food is broken down into glucose, and the stomach and digestive system is normal. That glucose then moves into the bloodstream. The pancreas starts to produce insulin, which moves with the glucose through the bloodstream to all the body cells, which needs glucose for energy. However, the glucose can't always get into the cells because the locks of cell doors have become fed up with fat deposits. That means that the insulin can't open the cell doors properly, so the level of glucose in the blood continues to rise. In response to this, the pancreas produces even more insulin, so the blood glucose level continues to rise as the insulin level continues to rise. This situation is further complicated by cells who are desperate for energy, sending out emergency signals to the liver to release stored glucose. The blood glucose level goes up, and the pancreas produces more and more insulin until it can't cope anymore. Eventually, it wears out. As with the type 1 diabetes, the symptoms of type 2 diabetes are frequent urination, thirst, thrush or gentle itching, slow healing of wounds, blurred vision, tiredness, and weight loss in some people. The symptoms of type 2 diabetes come along very slowly, and some people don't have any symptoms at all. So for that reason, The people with type 2 diabetes can live up to 10 years before they realize that they have it. Type 2 diabetes come between a number of ways. Initially, it may be sufficient to make changes to the food you're eating and to take extra physical activity or lose any weight that may be appropriate. But type 2 diabetes is a progressive condition, and most people will need some form of medication to treat it.
The last is the gonads, the ovaries, and the testes.
The gonads, testes in males and ovaries in females, are important endocrine organs, producing steroid hormones that affects growth and development, as well as regulating reproductive cycles and behaviors. There are three major categories of gonadal steroids: androgens, estrogens, and progestins. Both males and females have all three types, but in different proportions. The testes primarily secrete androgens, the most important being testosterone. Androgens are generally involved in development and maintenance of the male reproductive system. Early in embryonic development, the presence or absence of androgens determine the sex of an individual. At present, a male develops, and in its absence, a girl. Later, during puberty, high concentrations of androgens initiate the development of human males' secondary sexual characteristics such as facial hair, increased musculature, then deeper voice. The ovaries primarily secretes estrogen and progesterone. Like an androgens in males, estrogen and progesterone in females are largely involved in the development and maintenance of the female reproductive system. As increased levels of estrogens and progesterone began to circulate in females during puberty, they cause the development of secondary sexual characteristics such as enlarged breasts, widening of hips, increased subcutaneous fat, development of the uterus, initiation of the menstrual cycle.
Each of these glands are critical to the proper functioning of your body. Do you remember them? The pituitary gland, the thyroid with parathyroids, the adrenal glands, the pancreas, and the reproductive glands. Superb! Do you know what's the best thing about the endocrine system? It's that it works day and night to keep the functions of our body in delicate balance. And yet, it all happens without us even thinking about it. The endocrine system is the silent conductor of the orchestra of our body.